All right, in the previous lesson, we took a look at numbers and we were trying to determine if they were prime, meaning that they were greater than 1 and the only factors they had were 1 in themselves, or composite, meaning that they had other pairs of factors. So now we're going to use that idea and we're going to find what's called the prime factorization of a number. Now, the prime factorization, which we will do in just a minute, we're going to use a method called factor trees. And I think this is a nice visual way to do it. We can stop a branch of a tree when we get to prime factors. Now, I went ahead and grabbed this out of your textbook. This is a table of prime numbers from 2 to 97. It is really worth your while to just read through this list and say, yes, I recognize that I don't have a multiplication fact that gives me 23 or 29 or 31 or 37 and so on. So let me show you what I mean with the prime factorization of a particular number. I'm going to do this problem more than, well, no, this one I'm only going to do once, but some of them I might do more than once and show you that there are lots of ways to get to the correct answer. All right, we start with the number 8, and we want to factor it. We want to branch into blank times blank gives me 8. You can use any fact you know except 1 times 8, and that won't get you anywhere. So, well, 8 is even. So I can do 2 times 4. Is 2 a prime number? Yes. So I will circle it. Is 4 a prime number? No. Since the answer is no, that means there's a way to factor it other than 4 times 1. And we all know it's 2 times 2. So I will circle those because those are primes. The prime factorization, and let me show you how Math Lab will want it written. It will want 2 times 2 times 2. That is the prime factorization. It is the only way to multiply prime numbers together to get the number 8. All right. Let's look at our next one. What is the prime factorization of 24? Now I'm going to do this more than once and you'll see that we get the same answer no matter how we proceed. All right, I start out with 24. Well, I do know that 24 is an even number because it ends in a 4. So I'm going to say 2 goes in there, go off to the side, do the division if you need to, but it's 2 times 12, and 2 is a prime. But 12 is not a prime, and I can think of another factor. I could say that's 2 times 6. 2 is a prime, but 6 is not. I can factor 6 as 2 times 3. That's a prime. 3 is a prime. Remember, keep your list in your mind or have it written in your notes. The prime factorization is 2 times 2 times 2 times 3. I recommend that you go from smallest number to largest number. Let's do the same one again. All right, let's take the number 24 and let's start a different way. You might say, well, if I can write down any fact I want to for 24, I know 4 times 6 gives me 24. And that's fine. But 4 is not a prime and 6 is not a prime. And if you're not a prime, you're composite, so let's get another pair of factors. 4, how can I get 4? 2 times 2. Okay, those are both primes. 6 is not prime, it's composite, and it's 2 times 3. What are my factors? 2 times 2 times 2 times 3. Well, let's do it one more time. What if when you saw 24, you said, I was thinking 3 times 8, because that is 24. 3 is a prime. 8 is not. It's 2 times 4, and that's a prime. And 4, which is composite, is 2 times 2. I'm going to put them from smallest to largest, and it's 2 times 2 times 2 times 3. So see, it didn't matter how I did each one of these, as long as when I stopped with prime numbers. Okay, so you have some freedom. Let's look at the prime factorization of 50. All right. Well, what do you think of when you think of 50? Because it ends in a 0, I think of 5 times 10. Well, 5 is a prime number, but 10 is not. 10 is 2 times 5. 2 is a prime, 5 is a prime. How will I write these down? 2 times 5 times 5. Let's do that one more way. Now, when you're doing these, you don't have to do them multiple ways, but 50. What if you said, I was thinking of 2 times 25? 2 is a prime. 25 is not. It's composite. And I could get 25 by saying 5 times 5, but those are primes. What do I have? 2, a 5, and a 5. So you can see that no matter how you start, as long as you stop with primes, you're going to get the right prime factorization. Let's do one. Oh, no, we have 2 more. Let's look at the prime factorization of 36. We'll only do this one time. 36. I'm not sure how everybody would start. Maybe 6 times 6. 6 is not a prime number. I can break it down further. It is 2 times 3, and those are primes. The 6 over here is also 2 times 3. Well, the ends of all my branches are prime numbers. It is 2 times 2 times 3 times 3. That's the prime factorization of 36. All right, the last one is kind of a large number. That doesn't necessarily mean it's hard. I have 675. Well, any number that ends in a 5 is divisible by 5. So it's 5 times, and I don't know off the top of my head, so I will divide. 5 goes into 6 one time. Bring down the 7. 5 goes in there 3 times. That's 15. Bring down the 5. 5 goes into 25 5 times. Okay, so it is 5 times 135 is a factorization. Now, 5 is a prime. 135 is not, but it ends in 5. So, here we go. It's 5 into 135. That's 2 times. 2 times 5 is 10. Subtract for 3. Bring down the 5. 5 goes in there 7 times. So you might not have thought of it, but it's 5 times 27. That's a prime. Now 27. It's not even, so 2 doesn't go into it. 5 doesn't go into it. Let's try 3. We probably all know that 3 times 9 is 27. So 3, 9. 3 is a prime. 9, 3 times 3. You begin to whittle it down and the numbers get smaller, they get manageable. When I write the prime factorization, I want 3 times 3 times 3, because I have 3 of them, times 5 times 5. And that's my prime factorization. No matter how you started this problem, this is what you'll turn up with. Okay? I would suggest that you put in your notes this table of primes that goes up to 97. That will be helpful.